Hello friends, welcome to our channel. In this lecture, I would like to explain another topic that is based on this prestressed concrete beam. See here what is the given data. A simply supported prestressed concrete beam of span L. So entire beam that is span L 6 meters is of symmetrical I section. So this is the 2D view of that particular I section. So which is the given data. The flange will be around 300 by 60 mm. So both flange will be equal, flange 2 and flange 1. So that is the reason it is comes under symmetrical I section. And again web thickness will be given 60 mm. So the web height will be given 180 mm. The overall depth of the beam will be 300 mm, and the width of the beam means each flange will be consist of 300 mm. Then it is provided with 60 wires of 2.5 mm diameter. So I am taking here A will be equal to some 60 wires of 2.50 mm diameter, equally distributed in the top and bottom flanges. The beam has to support a superimposed load in addition to its own weight. That one will be equal to 2 kilonewton per meter. In addition to its own weight. A moving load, point load, causes an additional bending moment of. So a moving load. So in additional bending moment, that one will be equal to 5.60 kilonewton meter. So the beam has to support its own weight during the prestressing stage. Determine the stress distribution for the midspan section during transfer of prestress and after the action of the other loads. Allow 15% loss at transfer and further 10% loss subsequently. The initial prestress in the wires will be given 1075 Newton per mm square. So each and everywhere we have to remember only one thing. Determine the stresses at the midspan section. So you will get only one formula whenever the tendons place exactly around the centroidal axis, that is P by A plus or M minus M by Z. See here how you have to find out this I. For finding this I for rectangle, you know area will be equal to B into D. For I section, what is the formula? Area will be equal to this first one, B into D, and again this second one, B into D, because of the I section, and this third one, flange, plus B into D. So you can find out area based on this like this. And again, if you want Z value, for rectangle, the Z value will be different. That one will be equal to BD square by 6. Directly you will get BD cube by 12, again D by 2. For this type of I section, if it will be symmetrical, you will get like this, capital BD cube by 12. I am giving the hint how to solve this formula problem directly. And again minus small BD cube by 12. So BD cube by 12 means entire this I section along with this rectangular part will be covered. Later we will remove this excess part for finding this I section. I will show you how it will be. And again, so for finding Z, that one will be equal to I by Y in the symmetrical I section. And what about this Y? Y equal to maximum distance by 2 you will get. And again M value. So for finding this M value, here there will be some different conditions will be given. What are the conditions? So clearly observe the question. One will be given superimposed load of 2 kilonewton per meter in addition to its own weight. And another one will be given moving load cause an additional bending moment of some based on the data. But here the beam has to support its own weight. Means own weight means self weight. So first step what we have to do means the beam has to support its own stage during the prestressing stage. Means in the prestressing stage the beam has to support its own weight, means which is dead load of the beam. So first we have to find out the dead load of the beam. For that we have to find out the stress distribution at the midspan section during transfer of prestress. And again means the transfer of prestress will be around 15%. Means first we have to find out this transfer of prestress for 15%. Again we have to include this 10% loss. So you can follow how I will do one by one clearly. And again how we have to find out this P value. So in the last problem, P value will be given directly 960, which is the prestressing force exactly along the centroidal axis. But here P value will be not given. We know force will be equal to stress into area. So already initial stress will be given around 1075. area will be how much? Wires will be given 60 into pi d square by 4. Like that you will get a stress into area. So I will come based on the given data step by step. First I will find out this I value. See here what I will take I value. I value equal to capital BD cube by 12. 300 into overall D. 300 cube by 12 minus, so this is small b. So we covered entire part 300 by 300. Means next we are removing this remaining stage what I am shading here. So that is in the overall 300 we are removing this 60 thickness. Means 300 minus 60 is 240, which is B. In the overall 300 height we are removing this height 60 300 minus 60 means 180 into capital D means small d means 180 cube by 12. If you simplify this one, how much you will get? You will get around. So you please simplify in your calculator and take down the exact value what you will get. 5836 10 to the power of 8 mm power 4. And again I told you maximum distance y value will be equal to capital D by 2. So which is exactly at the center. So y value will be equal to D by 2, which is 150. So finally how much you will get Z value? So Z value will be equal to I by y, that is 5.583 into 10 to the power of 8 mm power 4 150 mm. So totally the value will get section modulus Z value will be equal to in terms of mm cube, and if you simplify you will get around 3722400 mm cube. So again the dead load of the beam. So next value is I am going here for finding the M value. For finding this M value we need W value. So for that first you are finding the self weight of the beam, which is dead load of beam. So I told you so many times, if it will be a rectangular one we can find out B into D into in the unit length 1 meter into 25. So that is B into D into 1 into 25 for the rectangular beam. So we are finding dead load of the beam. But here I section will be given. So for I section what we have to do means, so this is the I section. So for this type of I sections what we have to do means area. So here B into D in the sense area only, we know that one. So area into, so in the overall length how much given in the question, the overall length will be given around some 6 meters. In the 6 meter we are just finding only for 1 unit. So that is the reason area into 1. Again unit weight of prestressed concrete, that is we are taking here exactly so 25. Okay, if the data is given in the question you can take down that one. Okay, then so the total value will be in terms of kilonewton per meter cube. Finally you will get kilonewton per meter. So area will be in terms of mm square m meter cube, and meter cube will be cancelled here, you will get kilonewton. So we are taking per unit, for that reason you will get a kilonewton per meter. If you simplify what is the area here, first if you know this area we have to find out the area. So here already I shown you in roughly, so I will find out here only the area. So here see here the area B into D will be equal to 300 into 60 plus again this B into D 60 into 180, and again this one 60 into 300. So if you simplify directly in your calculators, directly how much you will get? So the area will be around 46800 mm square. So the same value substitute here. The same value substitute here. 46800 into 1 into 25. So this will be generally in terms of meter. We can convert that into kilonewton per meter. We can convert into mm. That is the reason here area is in mm square. You will get 10 to the power of 3 square. That is 10 to the power of 6. So how much you will get finally? You will get around 1.17 kilonewton per meter. So generally here this value will be in terms of 25 kilonewton per meter cube. So the value here obtained value will be mm square, and this one will be in terms of kilonewton per meter. So if you want this value in meters, what we have to do? Mm will be equal to 10 to the power of 6 by meter. So that is the reason we are taking meter upwards. 1 meter equal to 10 to the power of 6. So 10 to the power of 6 will be downwards. You just simplify directly, you will get. So the overall value, whatever you want, it will be in terms of kilonewton per meter. So the value will be around 1.17 kilonewton per meter. So after that, what we have to do? After finding the dead load, which is W. So we know the condition after finding the dead load. Next condition is M value. So again, I told you in the last problem also, for finding the maximum bending moment, whenever UDL will be given, that is WL square by 8. Here the dead load will be given. For the own self weight, we are taking 1.17. The overall span will be 6 meters. That is 6 square divided by 8. How much you will get? You will get around 5.265 kilonewton meter. So this is the bending moment what is obtained here. And again, so what are the values obtained here? P by A plus or minus M by Z. If you see here, we calculated Z, and again we calculated M value, and again we calculated A value, but only P value will be pending. So already I told you, force will be equal to stress into area. So we compressive force will be equal to compressive stress into area, which is initial stress is given, that is 1000 into area will be already given. A will be equal to 60 into pi d square by 4, that is 2.52 square by 4. That one will be equal to how much you will get? 294.52 mm square. So again you can substitute the area here, 294.52. So finally this area will be in terms of mm square, and initial stress will be given in terms of Newton per mm square. Finally the force whatever obtained here, you will get in terms of kilonewton. So that is how much? P value will be equal to here the initial stress value will be given 1075. I am taking here clearly 1075 into 294.52. So if you simplify this one, how much you will get? The pre-stress value will be around 316609 kilonewton in terms of Newton here. Okay. So this is in terms of mm square, and the value will be given in terms of Newton per mm square. Mm square cancel, you will get total the value in Newton. And again, for substituting the overall value P here, we have one condition in the question. You can see clearly. I will show you once again what is the condition given in the question. See here it will be given in the prestressing stage, own weight will be considered. We consider only dead weight only. So determine the stresses at the midspan section during transfer of prestress. First condition is transfer only. At how much transfer it will be? Allow 15% lateral transfer. So we are taking that one here. Okay. So if we allow 15% transfer, allow 15% loss at transfer for the prestress. So 15% means 100 minus 15, you will get around 0.85. So whatever the prestress obtained here, you can take down. P value will be equal to 0.85 into 316009. Okay. So this will be around, you will get 269,117.65 approximately. So whatever the value obtained here, you can substitute the value directly. Okay, that is what is the extreme stresses at top and bottom. So that is P by A plus or minus M by Z. So that is 269,117.65. So first we are finding P by A divided by 46800. So that one will be around 5.75 Newton per mm square. And again we are going for M by Z value. So what is the value of M by Z? Here what is the moment value? So moment will be equal to 5.265 after finding the WL square by 8. So I think I shown where I find here W value. See here 5.265 kilonewton meter. So that is in terms of Newton 10 to the power of 3 mm into, that is per meter into mm, it will be 10 to the power of 3. I will show you here. 5.265 kilonewton meter divided by Z value. How much Z value will be obtained? 3722400 mm cube. Just to go previous, means before paper, and you can check where Z value will be obtained. So see here. See here, Z value will be 3722400 in terms of mm cube. See here again. First, always you can make it clear. We are finding in terms of mm cube or meter or Newton. So finally here the value is Newton per mm square. We can change the values into Newton per mm only. So bending moment will be around Newton per mm square only. For that one, per kilonewton into Newton, it will take 20 to the power of 3. Per meter into mm, it will take 10 to the power of 3. So like that you can convert, you will get Newton, and again per meter square. Meter and meter mm square cancel here. Mm and mm square cancel, you will get mm square. Okay. So if you simplify this one, you will get around plus or minus 1.41. So this is plus or minus m by z. So first, extreme stresses at the top, that one will be equal to 5.75 plus value 1.41, and at the bottom 5.75 minus 1.41. So the extreme stresses at the top and the bottom, if you add this one, how much you will get? You will get 7.16 Newton per mm square, and bottom you can neglect that one, 4.34 Newton per mm square. So these are the extreme stresses and at top and bottom. Okay, that is 7.16 and 4.34 Newton per mm square. Okay, after that we have to draw the diagram. Finally I will show you after completion of the question. If you observe that one, we completed only first part, that is which one? You can see here we can complete it up to transfer of free stress after the section, that is allowing 15% loss at transfer, and a further 10% loss subsequently. So here we can also add further 10% loss subsequently. For this 10% loss, what again we have to consider? Again we have to consider some other loads, that is moving load and including live load. So I will show that one here. See here, allow 15% loss at transfer. Before that you can read the question. The beam has to support its own weight during the prestressing stage. Determine the stress distribution for the midspan section during transfer of prestress. Means at the prestressing stage, means during the transfer of prestress, there will be only considerations of the dead load. After the action of other loads, we have to go for the further 10% loss also. So that is the question what we have to remember clearly. So for that purpose, what we have to do, we can see here again the same formula we have to go through. For that one, we can allow some more loss, that is 10% loss extra. So already 15% will be given, again 10% will be considered, totally 25%, that is 100 minus 25, which is 75% we have to consider, that is 0.75 in terms of percentage we have taken here. Means so that is the first point. And again what is mentioned in the prestressing stage, they are considered only dead load, but here after that what we have to consider, both dead load, live load, moving load is given already in the question. What is the moving load here? The moving load is given 5.60 kilonewton per meter. So already dead load will be obtained in the question. What is dead load? So dead load will be taken 5.265. Already we substituted based on the area into 1 into 10 to the power of 5. And again what is live load? So for this live load, again you can go to the question. Superimposed load will be given. So see here, I will show you clearly. So see here, the data is there. The beam has to support a superimposed load, that is 2 kilonewton per meter. So we have to consider live load, that one. Means W will be given, we have to find out moving. So this is movement, not WD. So this is the moment based on this dead load. Okay, this is the moment given based on the moving point load. Okay, this is ML, this is MD. Okay, we have to find out WL will be given, that is 2 kilonewton per meter. Based on that we have to find moving live load, that is WL square by 8. So W will be 2 kilonewton meter will be given, length of the span will be around 6 meters will be given, divided by 8. So how much you will get totally? 9 kilonewton per meter. So the total bending moment will be equal to dead load bending moment is 5.265 plus live load bending moment is 9 kilonewton meter plus moving point load will be 5.60. Totally you will get in terms of how much? 19.865 kilonewton meter. This is the M value. So here the question will be the stress will be P by A plus or minus M by Z. So A value will be same as it is only. Z value means B M. First we can go for the M value. Already M value will be open. Again Z value will be equal to BD cube by 12. Again D by 2. Okay, that one will be same. So here P value only changes. So for changing that P value, what we have to do means we can take the initial stress, that is further loss, that is 0. P will be equal to 0.75 into this P value. So otherwise you can do like this. P will be equal to stress into area. So what is stress here? 1075 into that area will be approximately how much obtained here? 294.52. So you can consider this P value will be equal to directly after substituting this value. How much this value will be? This value will be 316609. So that is 316609. So simplify, how much P value will get directly we will see. See here, after simplifying you will get around this value will be 237456.75 in terms of Newton. And again, so first we can find out the P by A value. Extreme stresses due to the prestressing force, that one will be equal to, so here P by A will be equal to 237456.75 divided by area will be equal to 46800. So that one will be equal to 5.07 in terms of Newton per mm square. And again M by Z value. So what is M value? Total bending moment will be already taken, that is 19.865. So that this was in kilonewton meter, and again Z value will be given 3722400 in terms of mm cube. So again the same concept, kilonewton into Newton 10 to the power of 3, meter into mm 10 to the power of 3. So overall you will get a Newton, meter mm cancel, you will get mm square. If you simplify this one, how much you will get? Finally 5.34. So extreme stresses at top will be equal to P by A plus M by Z, that is 5.07 plus 5.34. That one will be equal to 10.41, and extreme stresses at bottom will be equal to 5.07 minus 5.34 minus 0.27 you will get. Both are in terms of Newton per mm square, Newton per mm square. So after that we know you will get a positive value will be like this, negative value will be like this. So this is 10.41 and this is minus 0.27. So this is for loss, further loss of 10% extra, that is 25% loss. So finally you see the diagram how it will be. I will show you here. So direct value. See here. So at transfer stage, top will be 15% loss. At the stressor top will be 7.16 and bottom will be 4.34. Both are positive. Therefore, you will get both are towards right. And again further 10% loss means overall 25% loss stage for the I section. One will be positive, another will be negative. So this is the reason you will get one will be positive, another will be negative. So we can add both these two. So this is the final stresses diagram. First for the transfer and again further loss for the 25%.